RMI stands for Remote Method Invocation. This is nothing but a distributed application in Java. Now the architecture of RMI goes like this. RMI is basically used for, let's say I have a object residing in one machine and that object has to be accessed from another machine to invoke the methods or the business methods of that particular object. And when I invoke the business methods of that object, it goes to the server or the machine on which the object is residing, executes the method, returns back the result to the caller. So the architecture goes like this. On the client side, we have what is known as a stub, the RRL, and the transport layer. On the server side, we have the skeleton, the RRL, and the transport layer. The transport layer is responsible for keeping the connection between the client and the server. On the client, we have a stub. A stub is nothing but a proxy for the object. As we said, the object would be residing in one machine that's called as a server. So we have an object at the server, and you would like to invoke that object out here, the method on that object here. So I need a representation of that remote object at the client place, and that's the stub. So stub is the proxy for the remote object. Just like how you would have represented probably your friend in a classroom, that's how a stub represents a remote object out here at the client side. When a client makes a call on the remote object which is residing at the server, the call comes to the stub. The stub then passes that request to the RRL. RRL stands for Remote Reference Layer. RRL identifies the type of server, that is, whether it's unicast or multicast. RMI supports to unicast servers. That is, unicast means you cannot replicate the objects, whereas multicasting you can replicate the objects. In the RRL layer, there is an object that is available called as a remote ref. Remote ref. The stub, once it gets the method call, it invokes a method on the remote ref to pass across the method request to the server side, RRL. From this RRL, the method call gets passed to the skeleton. The skeleton then invokes that particular method on the appropriate remote object. The method gets executed therefore at the server. The result of the method is passed back to the skeleton. The skeleton again passes back to the RRL here to the other side, to the client side back again, and the result is given to the stub. The stub produces the result to the client. Now we need to still look at what other things are happening during this communication. That is, when a client makes a request on a method of the remote object, the method could be taking parameters. Now those parameters could be of different types. That is, it could be primitive types, it could be object types, and if it is object types, it could be a local object or it could be a remote object again. Now when a method call is made with the parameters, if it is primitive data types, what the stub does is, it does what is known as marshaling. Marshaling means putting together parameters. Along with that, after putting the parameters together, it has to attach the header details and then push across the method request to the RRL by invoking a method on the remote ref. It invokes a method called invoke on remote ref. Now, if it is a primitive data type, then it just puts together all the values of the primitive data type and sends it across during the marshalling process. If it is an object, the object has been created here at the client side. I cannot just send the object across as it is, because then I am sending an address across. If I send an address from client to server, the same address on the server means totally different. So whenever I have to communicate or pass across an object across JVMs, as we mentioned during the stream class and explicitly during serialization, we need to serialize the object and send it across. So during the marshalling process, if there is an object as a parameter, it marshals, during the marshalling, it serializes the object and sends across the object as a serialized content. Now the object, we said, could be a local object or a remote object. If it is a local object, I have to serialize that local object and send it across. If it is a remote object, just like how I am accessing a remote object which is residing at the server as a representation of a stub, if the object is a remote object that I am passing, then I have to serialize the stub object and send it across. So again, stub is responsible for marshalling the request parameters for the method. If it is primitive data type, it just takes the value. If it is a local object, it serializes that local object. If it's a remote object, then it serializes the stub object and sends it across. When the method call comes to the skeleton is responsible for unmarshalling. That is, to recreate those objects. So it passes the primitive values as values themselves, and any local object that had been serialized and passed across, they will be deserialized, that is, it recreates the object. Any remote object that has been sent across, it deserializes the stub object and you get the stub object on the server side. And the method call is made, therefore, on the remote object. Now let us see what happens when a client makes a call to the remote object. Let us say on the server I have many objects like this. When one client makes a call to a remote object, it opens a socket for that client at the server for that particular remote object and communicates with the client for that remote object using that socket. So if I have another client, for this client again another socket is opened to communicate with that object. Similarly, this client wants to talk to another remote object, another socket is opened to talk to that object. Now what is the protocol that we use to talk to remote objects? Now it was previously called as a JRMP protocol, or otherwise known as a RMI protocol. This is a proprietary protocol. So RMI works with only Java to Java communication. JRMP stands for Java Remote Method Protocol. RMI we already know, Remote Method Invocation Protocol. Now, although we use the RMI protocol or the JRMP protocol to talk to a remote object, when I go through the network layer, it is the TCP/IP protocol that it uses. to communicate between two sockets or two machines. The default port on which it listens is 1099. Now, in order for a client to get the stub reference, how does it go fetch the remote object? First of all, in order for a client to invoke a method, I need that object reference. The object is actually residing at the server. So, how does the client get a reference of that object type which is residing at the server? For any remote object, we must define an interface. Interface is a binding between, or it's a contract between the client and the server saying what business methods would be available for a client to call on that particular remote object. So, we write an interface. That interface would be available both at the client and the server. At the server, you will have an implementation of that interface and an object created for that implementation. So, the remote object is residing at the server. The class is not available at the client. If the class would have been available, the implementation class would be available at the client, then it becomes a local object. So, when a client wants to talk to the remote object which is residing at the server, first it needs to get the reference of that remote object. What the server does is, once it creates the remote object, it places that remote object onto what is known as a RMI registry. So, this RMI registry is nothing but a naming space on which the objects are placed. So, I place the reference of O1, O4, O2, O3 onto RMI registry. Now, RMI registry itself is another application. So, it is a different JVM. Now, we got therefore 3 JVMs: client, server and the registry JVM. Onto the registry, these objects are placed with a unique name, which is called as a bind name. The client, when he wants to get the reference of any particular remote object, he needs to know for which remote object what bind name has been used. So, in the client program, you are going to specify the bind name to look up for into the registry. So, client will look up into the registry by giving a bind name, and against that bind name a particular reference would be stored, particular object would be stored. That particular object reference is returned to the client. Now, object O1 has been created at the server. When the server needs to bind the object onto a registry, the server is going to talk to the registry using the bind or the rebind method, which we will discuss little later on that. And when it uses the bind or the rebind method, it specifies the bind name for the object and the object which it wants to bind with. At this point, the registry is a server, server is a client to the registry, and again we are talking about remote method invocation, because we are invoking a method onto the registry to pass across the object with a bind name. So, once we invoke the bind or the rebind method on the naming interface, which is a common interface available to both registry and the server, and that is a remote call. So, therefore, even for a registry we have a stub and skeleton concept. The stub is automatically loaded to us, dynamically loaded rather. Okay. So, we pass the bind name with the object to the registry. That object that you are passing, remember, naming.bind or rebind is a remote call, and the object that you are passing to the method is a remote object. So, when a remote object is a parameter to the remote method call, how does it pass across the object? It cannot pass the address, obviously. It passes it as a serialized object. But does it serialize O1 itself? No, it serializes the stub object and sends it to RMI registry, because when I pass O1, it's a remote object, it's not a local object. So, the server, when passing the remote object, it is actually in the RMI call, it actually takes the stub, serialized object of the stub, and sends it to the registry. So, now that gets placed into a registry. Now, once the object has been placed in the registry, now